Well, while we're on the psych thesis of master
Now let's have a look at the
masonry
difference of the
and
differences.
stonework for headstones,
If
about
we
terms,
take
of
this
area,
term here
and just square it up. About
and we subtract from it
every grade from
this
preschool to
term
doctorate,
here,
PhD.
what do we get? Well, let's have a look at the VB term. We've got a minus VB
That's what I'm looking
and a
for.
minus minus VB. That becomes plus, so we get a minus plus is 0. We get no resultant VB term. Let's look at VC. We've got a plus VC minus VC. The VC term goes. VD, we've got a minus VD minus a minus VD, so it's plus,
Microsoft always
minus
like that's
plus.
gonna play great to the NP problem.
The
Throw in the
VD term
buttons.
goes as well.
Got it.
What about VA? We've got a minus minus, so that becomes a plus. So we've got VA, and then we've got for VA prime, we've got a minus, minus, minus. So 3 minuses make a minus, so that becomes minus VA prime. And that's the difference of differences. That's going to be the change in the vector as it is parallel transported around that parallelogram. As I say, in flat space, no problem. dv will be 0 because there won't be any change. It will just parallel transport round. It will come back to the same magnitude and the same direction. But if it's in curved space, there will be a difference, not in length, but in angle of the vector.
And yet the math.
Now let's
will
take
be
this first term here,
identical.
VC
Thing you
minus
could
VD.
trust the
What
first
actually is
time.
that?
Thing you
Well,
should
that
have
is
trusted
the
the second
change
time, and now
as
that you're
the
back,
vector goes
you don't have
from
much of a
C
fucking
to
choice.
D along a distance dx mu. So VC minus VD
I gave it to you. All the
is
room on
simply
that
the
reach you
change
needed out
in the
there.
vector along the distance x mu. That's the gradient, multiplied by the distance you travel, which of course is dx mu, multiplied of course by the vector itself. So what we're saying is
Because
that
you were
the
factoring all
change
that
in the
shit, but you
vector
were actually
between
just
C
this
and
little
D
prime thing down here.
is the gradient. Remember, we did this right at the beginning with our field. The gradient
It's almost worth
multiplied
it.
by
This
the
being a
distance
railgun, it's
times,
almost
of
like,
course, the
so it
value
messes
of the
all
vector.
this up after every shot.
But we've just
between
learned
this
that
end
we
of the
need to be
barrel,
very
this end of the
careful
barrel.
about ordinary
Bang.
derivatives when you're talking about curves.
This is
You
the
need
gas
to
release
use
on the 50
the
cal. You
covariant
become it.
derivative. So
Standing there
actually,
doing the 50 cal
to be
wave
more accurate,
particle
we better
experiment
call
at
this the
50 cal
covariant
through brick
derivative. So
wall or
instead of
just
using this
air.
gradient,
I mean,
we're going to
depending
use the
on
covariant
what some of
derivative
those things are about
times dx
all this.
mu, that's this term here, times the value.
And then
of
you
the
got,
vector.
then you got,
It's a much healthier way of doing it because we've just learned that you have to be very
well,
careful
Mario.
about ordinary derivatives when you're transforming between different reference systems. Now, what is this term VC minus VD minus VB minus VA? That is the
programming
difference
on
in
buttons
the
and toggles
differences
on zeros and
on
ones.
on a line which is separated by the distance dx mu.
It's a pretty steep
So
curve
essentially what you're
there
doing
on
is
that
you're looking
singularity.
at the difference of vectors with a separation of dx nu, which means you have to apply a new gradient to it. So VC minus VD
Ooh, boy, she got some trouble.
minus VB minus VA, which is this term here, which is, as I said, the difference in the vectors in
Does that mean
those two
stuff?
lines.
Does it need to be different like that in the
separated
real
by
world?
different
That
distance
length matter?
dx nu.
Like,
Well,
you gotta have it tilted at an angle.
we said that VC minus VD is
Is it supposed to be?
the covariant derivative times the distance times, well, that's, sorry, not nu, that is V times
We'll
the
just
value of
assume,
the vector.
yeah, alright, cool. Because that
But
rule
the
wasn't written,
difference
alright,
is essentially another differential, and it's the differential in the new direction.
That's bullshit.
So
I'm gonna
we've now
say
got
my
to add
fucking rookie comes up and gives me.
Covariant derivative in the new direction times the distance away. So that is effectively what that difference,
Did you do the magic there? It was?
that
Cool.
difference
I knew it.
equals. What about this one here? Well, this one will just be the opposite. In other words,
See how we did this
VC minus
backwards? That's what he's
VB
talking about. It is.
minus VD
That's
minus
really what he's
VA
talking about.
prime
And if you wanted to get to the VD about
is
it,
just going to be, well, VC minus VB will be the covariant
Zombies
derivative,
eating
but
people
this time
eating
in the new
zombies in
direction.
a third world country
now
because
we
their
need
people they died and they
covariant
thought they
direction
got
in the
their
new
fucking
direction
animal
times
spirit after
dx
3
mu
months of sitting
times
out
the
in the
value of the
fucking hot
vector.
sun.
But this
Killed everybody in
subtraction
town.
means that you're looking at the difference between this line and this line.
You said your Sams were the
separated by
T10.
dx mu. So
You
you're
shit about
essentially
paper in the
applying
government,
another
huh?
differential, but this time in the mu direction.
I'm pissed every
So we've now got
every
that term
time.
is essentially that term.
Wow, go back
and
up.
this term is essentially this
Cyclical
term.
models
And
on.
what we said was that if you subtract that, or if you subtract that term from that term, you get VA minus V A prime, which
Field
is
theory.
the difference
Nobel Prize
in
maybe if you do it
the
well enough.
vector, the difference
I
between
mean,
the
the
vector
bar
at the
is
starting
high.
point and the vector at the end point. So if you subtract this
Why
term
would
from
because
this
social
term,
sciences you didn't
you're
get this
going
part
to
of that?
get
Because this
dV,
was
the
that.
difference
The only
in the
thing is you're
vectors.
leading heavy in this over here.
So let's write it out.
Gotta have at least
dV
some of that.
is going to be equal to
I want to see
that
it.
term
That's bored.
minus that term, which is
I throw this down by
gamma
the time I'm
nu-
done. You'd have a board
sorry.
of 12 Texas
covariant
sheriffs
derivative
running my
mu,
numbers.
covariant derivative mu, doesn't matter which order we put these in, dx mu
Any
dx
12. You
mu
want to get the
v
fucking cartel that's
minus
pissed about
this
me inside
term,
of this court case inside
covariant
here
derivative
about
mu,
what'll go
covariant
down if
derivative
you
mu,
allow me to do
dx
this inside
mu
here. I'm going to turn your own
dx
fucking
mu
people inside
v.
of your own goddamn standards.
And we can pull out the dx mu, dx mu,
Gotta
and
get
v
it there,
because
though.
order again doesn't matter here. So that becomes dx mu,
That battlefield
dx
barbed wire
mu,
and
v
Feynman diagrams. Everything.
into what's left, which is
Carl Sagan
covariant
and Fogg nuked
mu,
Mars.
covariant
Well,
mu
Fogg nuked
minus
Mars. Carl
covariant
Sagan
mu,
universe low for that
covariant
thing. And
mu.
alright, so what he was really talking
That
about
you'll recognise, of
nuclear,
course,
how many
is
I
simply
have,
the definition of
the ice cap, the carbon
commutator,
index to the graphing schematics that NASA's going to hand me
which
the
is, of
numbers
course,
that I have
simply
to value to
delta
that
mu,
system. Well,
comma,
they've
delta
I'll give them some due on what that
deltas,
is, and if I factor
covariant
that value, that
derivatives
gives me
of.
something on the stock
But
index
you'll
over here, the
remember
job
that
models, the AI
equation
programs,
7,
doing
the
some of the math in
covariant
Ricci
derivative
or
is
Copenhagen
equal to
or
the
Tesla
ordinary
figuring out the
derivative.
schematics on
Incidentally, when I
what
write
the
dv
draw
like
for
that, what I really
timelines
mean
are
is
and
d
all this,
by
the factor of
dx
value
mu,
that's
it's
something
just a
sensible.
shorthand.
Isn't all this? That's a beast, man.
Plus
You're starting
a
with
gamma
like, well,
term. I won't
you
write
need me
out
to
the
make
full
a
details
one
of it,
stone
but there was a
mega
gamma term,
monument to
remember,
Buddha
that
out
was
here,
the
and
correcting
well,
term,
it can be
the
done.
Christopher's
However,
term. So wherever we have this covariant form, we remember from equation 7 that the covariant form is the ordinary derivative plus this correcting
That's
term,
bullshit.
which involves the Christoffel symbol.
100 mile
So
an
on
hour
that basis,
fastball build, or
the
supersonic
commutator
fastball
of
build, man. Honestly, I love it. I
which
love
we
the motivation.
identified before
It's good when you can do it real good.
is going to
Gotta
be
careful with
equal that times that minus that
Way too
times
far
that. That's
past
what a
numbers
commutator
where
is.
I could train you
Remember
something
that
in a course
the
over 12
covariant
years in a
derivative
high
is
school
the ordinary
or 8 in a
derivative
college.
times the
Step orders and
plus the
stuff. Well,
Christoffel
there's a
term.
lot more that goes into it
So
when you get
we now
into the 300
get that
IQ
is
of the skid
equivalent
steer when this
to,
thing
well, this
changes to
term
work in joules that have a
is
value that's going to Gauss curve your ass right into a tomb in this ground.
d
I make
nu
sure I
plus
factor it
the
for
Christoffel
the
symbol associated
Masons
with
about
nu
what hedge brokery
times
catching
this
5 cents
term,
out of their sand
which is
models
the
of
d mu
the
plus
2
the
pounds of
Christoffel
wheat, 2
symbol
pounds of
associated
barley
with
that go
mu
around here and
minus
values that change
this
things over.
term.
Somebody's ass is dead. Stuck their fucking dick right in that fuse box on me.
times this term.
Not this guy, apparently. He's looking pretty good.
I hope you can see that. And let's just multiply that all out. So we've got a d nu times d mu
The
term.
electrician would get it. He'd be like, yep. AC on the plumber
Then we've got
for the day. His old
a
man,
gamma
the plumber.
nu times d mu. Then we've got a d nu times gamma mu. And finally we've got a
You
gamma
see it.
nu
You do. The
gamma
ones and
mu.
zeros that hold up the struts on the support beams and studs
That's
inside here by
that
terms and
all
names
multiplied out.
have math. And I'll be
From
like,
that
oh, the
we have
stud's
to
out on that
subtract
when I'm catching the bill. Like, stud, house,
This
model,
term.
pressure,
Well, let's
water,
multiply
all
that
the
out.
time.
We've got a
And normally
d
with
mu
it, it's
times
this.
d mu.
Without that, Yeah,
Those should
definitely.
be curly D's, by the
Look
way.
over
All these
here,
should be
yeah.
curly D's.
You this deep into trying to get me out of
Plus,
money? Well, it comes easy.
We've got a d mu
Problem. Huh. All right.
gamma nu term. Then we've got a gamma mu d nu term. And finally, we've got a gamma mu gamma nu term.
Get back here to lockpick. Get me the hell off this farm, man.
Right, let's do the subtraction.
Crunchity click click.
d
crunch,
nu
click.
d mu minus d mu d nu is equal to 0 because for ordinary derivatives, the order doesn't matter.
Because it could come like that. Just
Gamma
tweak,
nu d
tweak, tweak,
mu
tweak.
minus d mu gamma nu, well, that's a commutator. In fact, that is equal to the minus the commutator of d mu gamma nu. Gamma nu d mu is equal
It's
to
something you find in
minus the
formula.
commutator of d
It's the only
mu
place.
gamma
It's the
nu.
only. It's the only. They don't allow mu's to run around other
We've
places.
got another
The only
commutator
place
here,
you'll
d
find is
mu gamma mu minus
Right,
gamma nu
formula.
d nu.
You're in it.
Well, that's just the commutator of d nu gamma mu.
You open the door. You close the door. It was like maybe.
Then
maybe.
we've got
Maybe
gamma
in theory.
nu gamma mu minus
Practice.
gamma mu
You clocked in.
gamma
And it's like,
nu,
wow, damn, buddy,
and
how
that
you doing
again
today?
is going to be the commutator of
In the
whoops,
Pokeball.
the commutator of gamma nu
Mu.
gamma mu.
That's right. Moo, buddy. Moo.
So just remind you that was the commutator of the two covariant vectors here, or two covariant terms here.
Get it right. Uncle
Becomes
Sam gives you a
this
little moo tag
term
over here in the ear, and then if somebody
But you
shoots
may
you out of turn
remember
and puts you in a
when
Pokeball that you don't
that
want to be in,
diversion to talk about commutators,
we'll
I
take care
said
of
that
it. We'll
if
get
you
you
have
back.
a function
We'll find
like
so the
that,
math wrong.
that equals the
Every
derivative
time.
of the gamma term
Well,
with respect to
I hate to
x
admit it, but
mu.
it is definitely that area over there. What do you mean?
And
It's
this
like, I don't know who
becomes
killed
the
Sally, but
derivative of the
over there.
gamma
What do you
term
mean? That's not gonna fix me.
with
Definitely fix the
respect
fucking
to
problem.
x nu. And this entire term is called
Maybe we'll let this one go. Just let
the
that one.
Riemann tensor. And
You
you'll notice that
dance
it is
monkey.
made up of Christoffel symbols and derivatives of Christoffel
Logic, yeah.
symbols. It's called the Riemann tensor. I can tell you that for our purposes, it is also and can be regarded as the Ricci tensor,
You don't
which
know.
we
You
need.
snapped that picture in there, and
That's
that's the
why
one
we
I
needed
caught.
to
Could have been
derive the
anything. You might have been
Christoffel
like,
symbols, because
oh,
as you can see,
but
the
I'm gonna be
Ricci
like,
tensor
oh.
contains Christoffel symbols and derivatives of Christoffel symbols. And the Ricci tensor, remember, was the
GPT-3
first
couldn't.
term
You'd see the wall
in
and you'd be
the
like, beep,
Einstein field
beep,
equations,
beep,
which I'm
me.
showing you
Up over
now,
that
just to
thing,
remind
ride
you.
around like the goddamn
So
dragon.
what we've just shown is that the change in the vector, remember the angle of the vector rather than the length, is equal to dx mu dx nu times v times the commutator covariant nu covariant mu, and that term we said was the Riemann tensor, but for our purposes it's also the Ricci tensor. So let's just take stock of where we've got to. We've just shown that the Ricci tensor is made up of
Nothing
Christoffel
physics, all
symbols
zeros and ones.
and the derivatives of Christoffel symbols.
Not
But
yet.
what are Christoffel symbols?
Soon.
We'll go back to equation 9, and you see that Christoffel symbols are made up of metric tensors and the derivatives of metric tensors. And what are
You can
metric
sit them down,
tensors?
get them to
They
stay
can be
inside here
thought
and get
of as the
inoculated.
device that you need to correct for Pythagoras on a curved surface. Now what I can also tell you is that from the Ricci tensor, R mu nu, you can derive what is called a curvature scalar. It is simply a scalar.
If you
It
do a
is not
Ricci,
tensor, not a
curvature
vector,
scalar,
just
gotta
a
have it in
scalar.
the tool cabinet.
Just
If
as,
not,
for example,
it's
if you
not-
take the
not
dot
Ricci.
product of two vectors, you get a scalar. You can
Through time,
take
they
the
carved their
reach
Jaeger path into the
tensor,
ground.
and from
Now,
it
whether
you
I like to admit,
create
I gotta
a
jump that
curvature
cane
scalar.
every once in a while
Point
to get to
about
where
that
I'm
is
going
if the
across
curvature
the Delaware.
scalar
You know how
is
it is.
not
You know
zero,
how it is, brother.
then
You on
the
the team, you're not on
surface
the team.
is not flat. Okay, let's just review where we've got to. We've covered the metric tensor, G mu nu. We've covered the Ricci tensor, R mu nu, which includes a lot of Christoffel symbols.
Get out there, gonna say some dumb
We've
shit,
covered
but
the curvature scalar, R. And so we've covered most of Einstein's field equations.
And I
There are
believe
just
in
two
that.
more terms to go.
I do. I believe in the gap
stress
between this
energy
you
momentum
doing
tensor,
the
T
worker
mu nu,
model, at least in the
and
Masons,
the
given
cosmological
certain
constant,
things that are
capital
different
lambda.
for.
But first, time for another break. Okay,
You know
we're
what?
now
I'll
ready
make you
to
one
do the
36
stress
and
energy
32 as
momentum
well, if you want.
tensor, T mu nu. What is the shortest distance between 2 points? Answer, a straight line.
No digress.
What is the shortest distance between 2 points, say, on the surface
Me looking at the
of a
boss with that
sphere?
drip of sweat coming
Not
down right
2
here,
points on
having
a
him
circle, but
decide
2 points
whether
on
I
the
need to
surface of a
finish
sphere.
off by the end of the day or
The
not.
answer is the shortest distance is what is called a geodesic.
Drip.
And on a sphere, on the Earth, for example, the equator is a geodesic. Any line of longitude is a geodesic. The shortest distance between 2 points where you have to go round a curve, you can't go in a straight line,
Walking
is
on
called a
sunshine.
geodesic.
Hey.
And we can define what's called a tangent vector, dx mu by d tau,
Chipping over pebbles.
as a rate of change of the distance that we travel with respect to time. I'm using tau because tau is what's called proper time.
They ask you what.
You can find out what proper time is from my videos on special relativity. The important point about
The brain's gonna
proper
need work,
time
and you're
is
not gonna
it
get
is
in
the
the
time
people
which
in the room.
all observers, no matter what frame of reference they're in,
It can be, but
agree
like I
on.
said, Ricci,
So if we
right?
use
It's like,
tau,
you want me to
we know
round
that
some
there can
ask
be
me
no arguments
questions,
about
not
what we
that,
mean.
brother, you don't know, right?
So we're looking about the rate of change of distance with time, and that's called a tangent vector. And what we want to say is that the derivative of that tangent vector must equal
My circle's better than his
0
brother's.
in order to find the minimum distance. So generally speaking, if you want to find the minimum in a curve, you take the